Just briefly, a little bit about me. So I'm a CTO and co-founder of a company based here in San Diego called Obrary. It's kind of short for the Open Library. We're a company, we specialize in product visualization as connected to manufacturing. So we have a sales experience API that we sell as a service to retailers, brands, and manufacturers that deals with real-time product visualization, largely in personalized products. So my kind of vector at this technical kind of interest was professionally motivated, not so much entertainment oriented. But basically, we're super excited about all things VR, kind of computer geek at heart, and I love to understand how things work, right? Which is kind of the path that I've pulled myself through to understand a bit more about photogrammetry as a method of capturing the real world, either environments or objects, which is really capturing objects is just really the thing that's more front of mind for me right now. What we really wanted to discover was, can we develop a cost-effective approach to capturing products, right? That what we do is product visualization. We want to take products for which maybe there aren't CAD drawings for, or products that just really only look and kind of work well in a sales environment, being, I would say, not synthetically generated, but things that look like real objects. And so for us, textures were really critical. And so I've been playing around with 3D capture for the last 2 years or so with a variety of different technologies, which we'll run through. I was never really satisfied with what it was that I saw from a texture quality or kind of across the array of different surfaces or widths and shapes and sizes. So I just hadn't stumbled upon anything where I felt like I could get a consistent capture. I always felt like I was spending my time going back and redoing it, going back and redoing it, going back and redoing it, which it effectively ruled out that as a company we would ever try and offer any type of professional services around that type of stuff. So questions. We want to do this. There's software that does photogrammetry, which we'll get into, right? Is there open source software that we can use to do that? So as a technology company, our company is built on top of open source software. We actively contribute to a number of open source software projects, and this is just the natural place for us to start. I like to tell people that if you're building a company today and you're paying for software to do it, you should probably stop and ask yourself whether you've made the right decision or not, right? And going back talking about doing it over and over and over again, one of the things I was really looking for was there a way we could come up to have a process where we could be very deliberate about capturing an item and have some assurance that we didn't have to go back and redo it again, right? And then what would we have to build as a rig to be able to capture objects, right? And so this was really formulated as a learning exercise for us to go through. And then ultimately resolving down to, is this something that we could pay a non-expert to learn and adapt to do? So when we look at the kind of the landscape of different technologies that are available to do, you could say volume capture or object capture, one of the ones that jumps to the top of the list immediately is an RGBD, right? So a color camera with some form of infrared sensing device that captures depth. And the most obvious one of those that exists today, and probably really one of the first ones to hit the commercial market, is the Kinect, right? So really neat, boom, overnight, all of a sudden this thing that cost basically, I think it was less than $150, you could do some pretty clever stuff with in terms of capturing. And then a follow-on as basically this almost the exact same device, but this one plugs into an iPad or an Android device called the structure sensor, which I have one here today. If anybody wants to get a capture of them kind of quickly, it's a good device for doing that. We can do that. Then, similar technology, but pushing up now into the commercial industrial space, you have devices like the Arctech EDA, where I think it's a $25,000 device, and most of that is the software, right? So there's a subtle hint inside there about how important software is to this workflow. And then there are new things that are coming around the corner, where Google has had this thing for the last few years called Project Tango, which is a structured light RGB, but really augmented with a lot of other extra sensors, and that's going to end up in your phone, right? So we'll say it, there's not a question about it. It's a foregone conclusion that in 5 years, there's like an 80 to 90% chance that your telephone will have this type of technology in it, and will be able to map objects, interiors, everything else. So, the 10-year horizon on this is that this type of capture will be fairly ubiquitous. the question becomes, what is the quality threshold of that? So then there are other solutions, so, that are focused more on, laser capture, where we started to use, more, tighter control around certain types of light. This little device up here was a Kickstarter called the Eora 3D, which is a little desktop little scanner, and it makes some really impressive looking scans, and it leverages much like the structure sensor, your phone, for a reasonable part of capturing. And then there's the DIY laser solution, for which there's a multitude of, but all of those really end up having the same, I'm not going to say problem, but put you in the same place, which is, bring your own software, right? And then, there's this other channel here where we talk about photogrammetry, right? And there are a number of software solutions for doing photogrammetry. So on the commercial end, and say this is a non-exhaustive list. There's a link down here if you just wiki. If you go to Wikipedia and search for this, there's a very expansive list with a grid of their licenses and capabilities. But these are some of the top shelf, or kind of regularly ones that own mind share when you talk to people about doing this. And then kind of down in this open source bucket, there's a combination of different tools that can be pulled together to do this. And so the focus of this talk is really around, specifically a tool called Visual SFM, another tool called, misspelled it actually, I think it's CMBS, and MeshLab. So, why photogrammetry? I've kind of hinted at some of it, which was I was never really satisfied with the quality of the textures that we could get, or the ability to capture across a broad array of object sizes. But this idea that we could actually now have a device that can capture at many, many frames per second, either in the form of video or pictures, and we could really completely capture an item and be done with it, and have this like finite investment where it's like we're done with capture, and unless we really screwed it up, we won't have to go back and do that. As an eminently appealing thing for us. Reality textures, right? So, we're taking pictures of the actual real items. They will be projected and put onto this virtual item, or this virtual object that we're creating. And so there are a number of great things that come along with it. It's a software-based solution, right? So we can take normal photos taken pretty much by any camera, and we can shove them through this process, and we can get something, we can get something out of it. There's a multitude of vendors, both free and paid. For us as a company, not everything that we work with our customers on, there are CAD files for, or that they would be willing to share those CAD files, right? So with the rise in digital manufacturing, it certainly makes it easier to copy things. Companies have concerns around their intellectual property. And the reality aesthetic, if you've actually looked at some of these really great photogrammetric captures, whether they're of objects or scenes, they're very compelling. They've got a look and feel to them that at this point you wouldn't be fooled for them being like totally real, but they're better than everything else. So what I want to do is just kind of try and take a large group and kind of get everybody on to hopefully close to the same page in terms of understanding some of the basic concepts of photogrammetry. So I'm talking, below you, sorry, I'm talking above you. Hopefully if you have questions, feel free to stop and ask. I'm more than willing to take those. So, but basically photogrammetry, this is the formal definition of it, right? Which is survey, mapping, measuring, distances between objects or points, right? So at a meta, kind of super high level, right? So when we talk about photogrammetry, really, and we talk about specifically the processes of capturing, really we're not really so much talking about photogrammetry as a process. We're actually talking about something else, which we'll get to. But photogrammetry is really just the super high level, generic, we're measuring between 2 points, using photography. Terminology, we have points, right, which is just a point within space. So we live in a three-dimensional, physical environment. And, any point can be expressed in that along 3 axes, right? And so a point is just a zero-dimensional space, right, at the intersection of those 3 axes, right? A point cloud is something that is really central to this, to the process of photogrammetry and structure for motion. Where really that's our objective. That's what we want to get out of the photos. What we want are the points. And those points represent important parts of the object that we're trying to capture. And specifically, from a given perspective, the distance between them, right? points have color, but they can't represent textures, right? So looking at a point cloud, you may see, and that point cloud may actually look pretty much like the thing, but as you get closer and closer to it, it's like that old picture of the pennies and Lincoln. I don't know if you guys ever saw it, right? But far away, it pretty much looks like the thing, but as you get closer and closer, you realize that really the data we're dealing with is just small individual points that potentially have color, don't have to, right? But in order to actually have a texture applied, right, we have to have a surface upon which to project that texture, right? And so now this is where really kind of all the magic really has to happen, right? Which is you can go find the points, that's one level of magic, right? And then the second level of magic is now which points should actually be connected, right? And that's a very complex domain of computer science and algorithms, and there's a number of different ways to try and solve this problem, but it's very difficult to have one algorithm that just kind of works evenly and well across, all different types of objects of different sizes, thicknesses, everything else. So in the context, certainly, of looking at this, of how do I do this with open source tools, this is a gritty and manual exercise at various steps throughout the process. And this tool chain has kind of come together. You can get from the front to the end, but you may not like what you get. And the reason why you didn't like what you get might be because there's 300 knobs in the middle that you could have dialed differently, right? So this thing I was alluding to here, what we're really talking about when we talk about photogrammetry is this concept of structure from motion, right? So photogrammetry being just the simple measurement of distance between points from a photo, structure from motion is now saying I'm going to present pictures of the same thing from different perspectives, i.e. the motion, right? And now, based on some fancy algorithms, we're going to figure out basically how far those are apart and what the basic structure of what that item is. So basically the idea that algorithms plus many pictures, we can actually start to derive a form out of it, rather than just a simple distance. So a simplified workflow for this process, right? So we have an item in the real world, we want to capture it, right? And so we go do that. And I've done that a number of different ways. We'll walk through some of the different examples. I've done it with video, which was kind of my dream, that, hey, we could just take video of this and just make sure we get everything, and then like we're done, and then we'll just pull frames out of it, and then we'll do our capture based on that. Or you could very deliberately take individual photos moving around it, or if you move up the capital intensivity scale, you could have a room with 100 and something cameras in it that all take a picture at the exact same time, and knowing that you've got a static representation, but a lot of data about that object at one point in time. And so there are companies that do that, and the scans that they make, they're unbelievable. You've got 100 plus SLRs, with expensive glass on them, and they're all hooked up and controlled by computer in a room with perfect lighting, and it's pretty staggering. It's pretty staggering the quality of what can be created. But basically, we capture the object, right? And then the first thing is now, okay, we've got a bunch of pictures, right? And that first step, right, is feature detection. So we take all these photos and we give them to an algorithm, and then it's going to go through and say, what are all the significant points, areas of contrast, corners, edges, and it will create point markers for those that it now kind of holds, and then it will start taking that across all of the images and comparing them together, looking for similarities, and it will try and cluster related photos together based on what it actually sees in them. So it's not saying that they're taken from the same perspective, but I think the same thing is represented in these N pictures, right? Which, of course, involves weighting, right? So, these tools very conveniently can push some of this work down to the video graphics card, which is very good at doing lots of parallel operations. And so this is one of these exercises where the bigger the video card you have, as long as it's an NVIDIA, you can actually make this process go quite a bit quicker than just relying on your computer to kind of, we'll just say, do it in software, but it's not. It's just doing it serially. So what you get out of that is now a set of matches, and I think these photos are all related, right? And now you can begin the real fun work of actually trying to compute the structure from motion and try and get a sparse cloud, right? So you wait longer for that, right? So there's more processing, and now you have something that is a sparse cloud, right? And then you can immediately basically step into, there's a review process. Do I like that? Did it actually take the object that I presented to it and realize that it was one object, or did it in fact end up thinking that it was 3 different objects in different places, right? Which does happen, right? So there's some intervention potentially that is involved in maybe going back and rerunning certain portions of the process to kind of take a picture out that might have confused it, right? And then you can go into this dense reconstruction where it's really going to now take the full resolution images and just try and get everything it can about it, the densest, richest cloud, right? But when you realize, just like when you take pictures, you're looking at the subject of the picture, but 80% of the information in the picture itself is actually not the thing you're taking a picture of, right? And so typically there's a trimming process where now I've done this capture, it's presenting me a cloud, but now I need to trim all the stuff that I don't really care off. And then this magic process of the mesh reconstruction, right, which is now kind of running another algorithm to try and tie these points together, and then the projection of the textures, the projection of the textures onto it. So in the context of the open source software, right, basically we have Visual SFM and CMVS, right, and then MeshLab. So these are the kind of the 3 pieces that we use to kind of glue to glue together a new mesh, right? So some of the comparisons that I've run here, both for the purposes of my own experimentation and for the presentation, were done with a circa 2011 point-and-shoot camera, right? So that was done largely for practical reasons. I do actually have access to nice, expensive cameras, but what I didn't want to deal with was 50 megabyte pictures for each one, and the amount of compute time that it would actually take to go through. And so it's a nice camera, but it's not new. It takes 12 megapixel images, so they're about 3,000 by 4,000. So they're not too bad, right? And I ran 2 experiments. One, which is a business card box, the other one, which is a full-size bicycle. Right? In this example, what I actually did was I took the photos and then I fed those photos through 3 different software packages. Sorry, one of them is Autodesk Memento, which is probably the one that comes easiest to mind for people who've played around with this technology. It's a cloud-based solution, so you present your photos, they get whisked away off onto somebody else's servers, and then they run the process on it, and then they push the data back down to you, which I haven't actually read it, but I'm sure with an irrevocable, royalty-free global license to do as they please with whatever you gave them. And this was the basic result. And I don't know if it's kind of hard to see on the projector here, but there are 2 of them that are actually really quite crisp, and there's one of them that's not. And the one of them that's not, most notably here, the takeaway is actually the commercial solution, right? So the open source solution came the closest to, we'll call it the best of breed solution, which was a surprise. So I actually have a walkthrough here, so we can kind of switch over, hopefully.
What are the pictures in the ground, the QR codes?
So the QR codes, so they're not QR codes.
Well,
I've learned, right? So because I was Googling for like QR codes to do it, and then I started reading more about the algorithm, and QR codes are too busy, but these are AR targets, right? So same thing, different name, right? They're just not as busy. I found these came from a Carnegie Mellon website, random, like it was like the 3rd list, the 3rd link in Google, and it was like, oh, cool, 9 shapes. So I printed them out, and I grabbed a cereal box and gave them to my kids and glue stick and said, make some parts, right? So, and this kind of occurred to me in some of the other testing that I'd done, where I'd gotten the algorithm had gotten the orientation of the object confused, and then I figured that by just putting something with high contrast, nice points, and an asymmetric pattern around it would help, which it did. So there are specific targets for some of the commercial software, like I forgot the name of it again. Agisoft actually has coded ones where they have special meaning to the actual algorithm itself. So you can wake it up and tell it, like, no, I'm putting these 5 targets in here, and that's the scale of them, and which is helpful at least in terms of getting the scale of the object correct. So this is a 3D capture of a bicycle made from what effectively was 52 images. Right? I actually have this open in MeshLab as well. not that one. Don't want to show that one to you yet. Maybe I will have to open it. Source, workflow, cycle. Yes. So jump to the back end of the process. So what it's doing right now, this is actually, it's opening a bundle. It's a fairly large set of files that were produced in the actual structure for motion process. And what we're presented with, this is basically the raw output from that capture. And this is the sparse cloud. You can barely make out, and probably not at all on the projector, that there's actually a bicycle there. But what I will do is I will import the actual point cloud. Can you guys see that all right? So here, and if we were to get close to any of these points, we could see that there's no mesh. It's just the points of contrast that it was able to pull out of the object. So if you actually wanted to look at the actual pictures, we actually have the actual pictures that were created. And these are the actual pictures that it was taken from. So it's about 52 pictures, just kind of walking around it, trying to get in close on some details, but doing that without losing at least one or two markers. Yes?
Quick question, does color contrast matter in these photos? Like I noticed you have kind of a blackish gray bicycle on a black kind of gray background. Like if it was like a bright green or some other color, would that help?
Lighting is certainly important in this, and so in terms of the uniformity of the points that you end up getting back, the big enemies are like high degrees of reflectance, because that light just goes somewhere else, but not enough ends up having effectively the same basic same expression. Right? So in this example, there are 52 pictures which it pulls together into this model. And if we were to look at what it actually reconstructs, the commercial solution does a reasonable job doing it, but you couldn't really put this into an environment and convince somebody that either that they would want to buy this thing, right? Or that it's in fact real. But if you come in here and look at certain features of it, it's really quite good, right? And of all the items that I've captured, I would say this is probably one of the more challenging ones, because we have tons of hollow space. We have very thin things like the spokes here, and probably not the greatest lighting, right? So another example that we went through here. Let's see.
So the hole underneath the seat, was that maybe kind of reflective?
Actually, it's carbon fiber. So, which I've learned only just recently, typically doesn't reflect a whole lot of light. So it's kind of like a bit of a black hole where the light shines on it, but it never ends up making its way back to the, at least not at a level where it crosses a threshold where the algorithm really kind of picks points out of it. It's just very smooth to it. So what I can do here is I'll actually open. Maybe I'll close this. Open it up. So I'm trying to transition over into the actual visual SFM application, just to show you kind of really what happens when this process runs. It takes a while, so unfortunately it's not something I can just like open up and let it start from the very beginning. But the good news is that it produces enough data that opening it is basically an accelerated simulated event of actually running it. So actually go here, got to open this up. Sorry. So here I'm just going to open up the project that I already had, and it's going to chew through a bunch of pictures that previously took a lot of time to do. But what it's actually doing now is it's updating the images. Sorry, so each of these cones represents a picture that it has determined, a position in space from where that photograph was taken. And so if we were to zoom in on any given one of them, we can actually see what the actual, what the actual photo is here. And so, this one you can see I kind of spiraled my way in. Started from the outside. I was trying to get a context shot so that all my inside shots wouldn't be lost, basically, against the outside. And, was able to see. This model took, on my computer at home, it's kind of old, but has a really good video card in it, with 52 images, took about 20 minutes to process. So that one's not too bad. There's another one that I have, which is actually a bit more complex, but is certainly more impressive. So this is one that I actually did not from photographs, but from a video. I actually took a video of my living room, right? So kind of cruising around, I'll just jump forward, and then I kind of, so the lighting's not fantastic here, but I tried to be deliberate and go around the items, kind of catch everything. I got this area over here with the kids' kitchen thing, and tried to come down and make sure, I want a kind of a straight on shot, so hopefully it'll figure out like to put one texture on that rather than parts of three. And so this video, if you look, I'm kind of swirling around the room and making this pass. If you actually look at what that looks like once it's open, we could see in this model there are a lot of individual photos.
How many frames did you skip?
So this was 6 minutes of video, and then I used another utility to basically pull a frame out of it every 1.5 seconds. So it's about 700 images, right? And this one took about 8 hours to run. So this was kind of just like, let's throw everything at it and just kind of see what happens. And I was very pleasantly surprised to see that, oh look, it actually works. Like, so with quite a bit of data. And as I mentally reflect on like what was the path that I took, it mirrors exactly what it was that I did. This section here is me actually walking up the stairs trying to get a big shot of the whole room. Now this mesh, if we were to kind of, do you guys want to see this mesh? We'll see what this one actually looks like. Let's make sure I haven't already opened it. I might have already opened it. So this is an unprocessed but fairly complete result. So there's a few goopy items kind of hovering in the room here that I didn't clean up before I reconstructed the actual mesh. But there are many items where you see like this was a thing of some interest for me here, was the little play set in the corner, which actually turned out quite well, right? So there were things in this capture that ended up not working really all that well, but when I look at why they didn't work well, I could actually map that back to, I kind of did a shoddy job, capturing that area, and if I had just spent a little bit more time. Now, in this approach, I could probably just go shoot another video and just like, since I'm kind of throwing so much at it anyways, and just kind of throw it in. The algorithms, when they go through, if they're pictures, and so when you take pictures, in case you don't know, there's a lot of other data that ends up in the picture other than just the picture data, like what camera it was, what the ISO speed was, what the lens was, what the aperture setting was, what the, all of these other things that the algorithms actually inspect to look at to try and compensate for it. The disadvantage of taking video is that you don't get that, right? So, piling up 600 images and just kind of throwing at it, if you had taken another video and thrown a little bit more in, I'm pretty sure it wouldn't have been able to figure that out. So, and this was, 5 minutes walking around, right? And I actually am left with the sense that if you were doing this outside, it would probably work a whole lot better. So, how did yours turn out, Joe? I'm sorry? So the video, it's 1080p start, auto exposure. So it's not that sophisticated of a camera. So I wasn't in specific control of the exposure either to do exposure compensation up or down. It was just kind of, there's a red button, you press it, it does 1080p video. So.
I did my home, and I did the same thing when I was like across the street, so we get a wide picture, and then sort of got a little bit closer, and I got really close to the front door and some of the trees and stuff. But I'm not tall enough to get the top of I don't have a drone, and so, you know, there were some things that were left to be desired, but it came out with a really nice mesh in the end, and you could bring them into SDVR or Maya or something and talk to it about them.
And that was, you know, my observation coming out of this was that doing the capture and kind of throwing it through and getting a point cloud out of it was a pretty deliberate, straightforward process. There wasn't a lot of stuff you had to do in terms of finding knobs to adjust. All of that really begins when you need to actually transition from having just a dense point cloud to actually converting it and turning it into a mesh. That's kind of where like the skill ramp starts there, right? You can get most of the way through it. So as I would see it right now in this comparison of commercial solutions versus open source, that's really the commercial solution will take you further into that process before you really have to understand.
Open source tools where like edit this stuff. You can mesh like this.
It does, but
I don't know how to use
you know,
it.
you know, I could probably count on my hands and toes the people who really understand MeshLab well enough to do that, or Blender for that matter.
Do you think 360 pictures can use the same software? Take that 360 picture instead of taking pictures from all the angles?
As I understand, you can. However, you have to undistort the images. So there's so much going on in the distortion that the algorithms can't really make heads or tails of it, and that you have to find some way to basically, you know, kind of unpackage the.
So you make a cubic 6 back of them, basically?
Conceivably, yeah. So you have to undistort the images so that the geometry is fairly consistent. Because what happens is that, like in that distortion, there's a different amount of pixel for a different amount of space, and you've got to unpack that basically.
Well, I don't think that these programs are modeling a 360 lens shader. Right? So it's all based off of actual photography and not 360 stitched together.
But that being said, the algorithms do incorporate knowledge of specific cameras and specific lenses. So down to the lens. So there are some of them where they go in, they're like, oh, that's a Canon 7200 at this, at this focal length. I understand what that means from a distortion. So there are algorithms that are actually modeling the characteristics of the lens to be able to manage that. Like the GoPro is the one that I think everybody wants, and it's not a traditional lens, but it's not a 360 either. It's somewhere in the middle. Is there a question over there? Yeah. So as I understand it, they're working on, or somebody, there's a hope that the Autodesk solution will be able to do GoPro before too long. So.
Have you ever played with HDR photography?
I have.
Because when you're describing some of the constraints and the troubles you had about reflectiveness, I was thinking that there might be some way that you could create like a custom HDR setting to essentially try to, depending on the lighting that you had, take 2 pictures and then use the best reflection from that angle to, whatever works best with the software.
Yeah, and I think just doing HDR photography in general would be helpful.
Yeah.
Right. As well as things like polarized lenses, like lens covers and stuff like that, would probably be helpful as well, just to cut down on as much of that as possible. Getting the software up, it's very straightforward, right? You can just Google Visual SFM. It takes you straight there. You can download it. You can open it up. You can throw a bunch of pictures at it, and minimally, you can get to this point. Depending on the speed of your computer, an hour or two, after jumping in, right? And so, at this point, we've already stepped through kind of the whole workflow. This is really a fully processed model, and it's at this point that you would actually step out, go into MeshLab, and work on now, actually reconstructing that to make it a proper, make it a proper mesh. So, let's see if I jump back here. So, I'm sorry? Yeah, so it is for non-commercial now, or it is a non-commercial open source license. I've contacted them about it. I haven't heard anything back yet, right? So typically, I would expect it to be cost competitive, and there are other ways of using the other underlying algorithms without Visual SFM as a tool. So Visual SFM is really just a wrapper around, a few other libraries that are actually doing the work, some of which have more permissive licenses than Visual SFM, as I understand it. So, and really, if you're doing this commercially, I would say this exercise for me was really more about how does it work than I have to find a free way to do this, right? It was more about how does the underlying technology work. So when I look at commercial solutions, should I go down that path, I'm more more appropriately informed in terms of what the capabilities of software are and what really is what's really worth it and not. Right? And I'm a big believer that over the long run, kind of open source software wins almost always. So. So we have another example. This one, fortunately, projectors not so high resolution. No, that's not going to work either. I can go through those. I don't want to kind of like drag everybody through my mesh lab exploring. But long story short, at the end here, which is now where my deck kind of left off, right? Which is as an exercise coming in to figure out like how can this be done? It is fairly straightforward to get started. There's a fairly steep learning curve that presents itself as you get into the mesh reconstruction part of that workflow. But I know one of the things that I actually have a much nicer version of that living room mesh. So in my Vive, my replacement room is actually the living room. So you now can put the headset on and they're actually in the same place you just worked, which was kind of my geeky objective at the very beginning of it, which is, wouldn't it be neat to be in the same room when you put it on and take it off? Because at least that way, then it's like I could walk over to the couch right there, and then I could sit on the couch, right? Which I find myself constantly wanting to put things on virtual tables and let go of them and have them actually fall into the floor. So kind of in summary around that, it's super interesting if you're kind of into the geeky facets of what's going on underneath the covers. This as an ability for us as individual consumers is going to change in a really significant way over the next 5 to 7 years, and all the things that we look at here will just be very easy to do in a handful of years. So, but yeah, any questions?
Point of reference, what was the computer spec so that we know compare?
So that 670 image one was running on a machine that had an NVIDIA 980 card in it, not a TI, but a 980. And the processor itself was actually about 8 years old. It's a multi-core, so it was a quad-core, proper quad-core processor, but it was a 9450, which was fabbed in 2008. So it's not a fast chip, but it was multi-threaded. So and that was the one that took the long time on the large block of images. So on this laptop earlier today, I was able to do one which has a much faster processor, but arguably a much weaker video card in about 30 minutes. So 50 pictures or less, maybe 30 minutes of compute time, which isn't too bad. Any other questions? Yes?
Does this process work for historical recreation of buildings that no longer exist and kind of find out from pictures?
Yes. Yeah, or video of old stuff. I think you sent it to me, right? Was the Shining one where someone recreated the inside of the building from The Shining from the movie itself. So they like basically took frame grabs of it and reconstructed it. Yes, those types of things are possible, and that is really, you know, on the surface, that's like one of the most compelling aspects of using this approach, which is, you know, you don't have to capture it today. It could be stuff that was captured from a long time ago. So.
This actually was something that's done that for something right out of class in the studio in the museum.
Where there were old photographs of it.
Yeah.
Yeah. And there's a gentleman who lives here locally named Cosmo Wendman, who's kind of a champion of capturing great sculptures and digital, you know, art, you know, sculptures and art, and making them available digitally. And so I've looked at a number of his sculptures, and it's compelling. I mean, you know, you get into a VR headset, and you know, you can walk up to it and look around it. It's you know, there are a few big industries that I can think of off the top of my head that are going to be completely disrupted by virtual, just kind of this ubiquitous virtual reality, and that's like the travel. You know, travel's going to be hit hard by it, but you know, another one's like museums. It's like, do you really need to go all the way to the museum to, you know, see this stuff? So do it in the comfort of your own home. So that's about everything I have. I have a few other examples. I can go through them, but you know, I don't want to kind of hog all the time. I think there's a number of demonstrations that everybody could do. If there are other questions, I'll keep going, but we could stop anytime.
How similar is this to the technology Google uses to, you know, building certain buildings now, and you know, they can actually move around? And is it a similar?
So are you talking about? So there are a few technologies that I'm aware of that does around this. So one of them is just, you know, kind of photospheres and like quantized positions with photospheres, almost more like a Matterport browsing experience.
Well, this one was like you can go into like a restaurant and you can like walk around, but I don't know if you can like position it like you're doing, like say I want it exactly behind the sofa or something like that. Like, is it a similar kind of thing? Or?
So if you do the demo over here, it might answer a few questions about that, because you know, a full photogrammetric capture of an area gives you a reasonable amount of latitude in terms of where you can go inside it. So you're not like here or there. You know, you can be anywhere in between, right? And I think in the experience over here, they kind of they put you on a road so that you're not looking at the empty backs of things.
Talk about one of those down the drone.
I don't think so.
It's almost like the inside street view.
Yeah, it's like they're walking around inside buildings, so you kind of feel like you're there, but it's not obviously the same as this, where I think in here you could literally say, I want to position myself in any quadrant.
In any kind of arbitrary point inside that space.
Right.
Yeah.
But I guess my larger question then would be, is what you're showing here, is this going to be kind of like, is this just like the poor man's way of doing it? So, you know, anyone, we could all with our
Yes.
age, you know, and with new technology then, like you're saying, there's going to be this new scanning methods on your phone.
Yeah.
Will this kind of blow the way of the dodo, or is this still going to be something that's...
So, you know, to the point of the historical stuff, I think this stuff will continue, you know, this type of technology will continue to be used. There's one major advantage that it has, which is the quality of the textures, right? So, and you can add that to other new emerging technologies, but the way that I would say we should expect to receive access to these new technologies as consumers aren't going to be so focused on the outright texture quality. They're going to be focused on speed, you know, orientational trueness, you know, and, you know, expense, i.e. making sure that that feature can be added to your phone and to slip in under your price sensitivity threshold, right? Because what Google wants is a map of every indoor space, right? And so the Tango